Okay guys, this is a quick little video on how a catalyst affects the rate of reaction. So we talked a little bit before and mentioned that the rate of reaction is determined by the activation energy. A really high activation energy means that fewer molecules have enough energy to get up and over the speed bump. So it's going to result in fewer effective collisions. Therefore, it's going to result in a slower rate. Because remember, the rate is not how fast each molecule gets up and over the speed bump. It's how many molecules can get up and over the speed bump in a short period of time, change in quantity over change in time. So really high activation energy would be something that is not very reactive. Let's say a block of wood, not real reactive, very high activation energy. Something at a very low activation energy. That might be something like let's say something like this. We'll draw it a little bit lower. So very low activation energy. That would be something like maybe like unstable, like nitroglycerin. And so here's what happens. Hopefully you watched the video, and the video was the elephant toothpaste video, which I always do in class. It's a lot of fun. So what happens is that's a reaction of the decomposition of hydrogen peroxide into water and oxygen. That's what makes all those bubbles, and the soap is what makes it fun because it's bubbly. If they have an enzyme involved, there's catalase, for example. They put it over the top here. Now, catalase is an enzyme actually that we have in our body. Enzymes are catalysts. They speed up the rate of the reaction. And catalyst is not used up in the reaction. So it can be used time and time and time again. It just provides, what happens is it provides an alternate pathway. So if you were to draw the effects of a catalyst, it might look something like that. So what it does is it lowers the activation energy and it speeds up the rate by providing an alternate pathway that's lower energy. And very important to note, it's not used up in the reaction. You can use it time and time again. So that's why enzymes are so critical in our body. If we didn't have enzymes, we'd eat food, and the food would sit in our stomach, and we would literally starve to death because we could not break down that food fast enough to get the energy out of it. So alternate pathway, here's what I like to say. Here's my example for that. So let's say you're in a castle, and you're on one side and you're trying to get to the other. So you could go all the way around the wall and finally arrive on the other side. It's going to take quite a while, fair amount of energy, but you could go into the library and pull that one candlestick that opens up a secret passage that takes you underneath and over to the other side of the castle. It's kind of what a catalyst does. It provides an alternate pathway that's lower energy. So last thing I want to mention is we have all kinds of catalysts. We have catalase actually in our blood. That's why when you put hydrogen peroxide on a cut, it bubbles because it's producing oxygen gas and water. We already mentioned enzymes are catalysts, and also you think of a catalytic converter. There's metal catalysts. That's what is in a catalytic converter. It's platinum. And again, it increases the rate of that chemical reaction, increases the additional combustion of those molecules.